Areas related to circles. We have made some formulas for finding the area of a sector and the length of an arc and the area of a segment. Okay, we'll just revise the formula, then we will do more exercise with the same formulas. If you are watching my videos first time, please subscribe my channel, and if you like this video, don't forget to press the like button and also share this video to your friends. So look here, the question. This is a question combining trigonometry and this chapter. Okay, look here, the shaded segment AYB, segment AYB shown in the picture. We want to find the area. Okay, radius is given that 21, and the angle AOB, the angle made by the joining the endpoints of the chord with the center, is given that 120 degree. We want to find the area of this segment. So we can apply the formula area of the segment is equal to area of the sector, corresponding sector minus area of the triangle. So here the area of the sector is very simple, but the area of the triangle, it will be little bit difficult because we want to apply trigonometry, the ratios. Okay, we can do that here. Okay, look here, what will be the area of the sector here? Area of sector first.
360, 120 by 360.
Okay, first we can write the formula x by 360 into pi r square. So x is given that 120, 120 by 360 into pi r square. Pi into r square, that is 21 square, 21 to 21, I will write it simply like this. Okay, so 120 and 360 can be cancelled. You know what 360, how many 120s?
1 by 3.
1 by 3, right? In 360 there are 3 120s. So this 3 and 21 can be cancelled. Okay, look here itself, the pi, for pi I substitute 22 by 7. So this 7 and this denominator 7 can be cancelled, right? So 21 into 22 will come. What is 21 into 22?
462.
462 will come, right? Okay, 462 unit square. It is given in centimeter. So centimeter square will come. This is the area of this sector. Now we want to get the area of this triangle, triangle AOB. So we can take AB as the base, and this line I shall draw here. If you draw a perpendicular from the center of the circle to this chord, we know that perpendicular will bisect the chord by a theorem in the 9th standard, right? So we will get two triangles. From these two triangles, we can calculate AB and also this height of this perpendicular, the distance to the chord. Okay, so suppose I give name M here. So you take one of the small right triangle. I take the right triangle AMO. I take the right triangle AMO. Here, look here, hypotenuse is given. And what will be these small angles, these two small angles?
60.
Okay, this will be 60 and this will be 30, right? I shall draw that triangle below. Okay, a triangle comes like this, here 30 degree, here 60 degree, and here 90 degree angle, and hypotenuse is 21. So we got a 30 degree, 60 degree, 90 degree triangle with hypotenuse 21. Okay, so we can apply the sign, the trigonometric ratios to find out the other two sides in this triangle. So we want to find out the this side. Suppose this side, suppose I take x, OM. So what will be the OM, length OM? Which trigonometric ratio we want to get? The hypotenuse is given. I think we can do with respect to 30 degree angle.
Sine 30.
Sine 30, right? So sine 30 will be equal to x by 21. What is sine 30? What is the value?
1 by 2.
1 by 2 is equal to x by 21. So what will be x?
21 by 2.
21 by 2. X is equal to 21 by 2. Okay. Then we want to get AM. What will be AM here? Which trigonometric ratio we want to take?
Cos.
Cos 30. Okay, cos 30. Cos 30 is equal to what will come? AM by AO will come. That is AM by AO is 21. So cos 30, what is the value cos 30? Root 3
Root 3 by 2.
Root 3 by 2. Root 3 by 2 is equal to AM by 21. Then what will be AM?
21 root 3 by 2.
21 root 3 by 2 will come. 21 root 3 by 2 will come. If AM is equal to 21 root 3 by 2, what will be the length of chord AB? Chord AB.
21 root 3 by 2 plus 21 by 2.
Yes, 21 root 3 by 2 plus 21 root 3 by 2. Or in other terms, we can just take the double into 2. So 2 into 21 root 3 by 2. 2 can be cancelled. So we will get a 21 root 3 as the length AB, or the chord AB, the length of chord AB. Okay, so we got a chord AB and the OM, the height. So in other terms, we can say the base can be taken as AB of this triangle AOB, and the height is OM. So we can find out the area of the triangle, right? So what is the area of the triangle?
Base into height.
Half BH. So substitute the values. Half into, okay, AB into, half into AB into H is OM. Okay, so substitute the values. Half into AB is, yes, AB we have written here, AB is equal to 21 root 3. Okay, into OM.
21 by 2.
Yes, OM I have taken as X and I have done here X
21 by 2.
21 by 2. We can write here 21 by 2. So we can simplify this into, the denominator will become 2 into 2, 4. Numerator 1 into 21 into 21. 21 into 21 is 441, right? 441 root 3 by 4 will come. Okay, so we got the area of the triangle and the area of the sector. So now using the subtraction, we can write the area of the segment, right? So we can subtract. Okay, look here. So area of the segment. Area of the segment is equal to area of the sector minus area of the triangle. So that is equal to 462 minus 441 root 3 by 4. So 21 is a common factor in 462 and 441. So 21 can be taken outside. So 21, not 22. 21 can be taken outside. So in 462, there are 22 21s. In 441, there are 21 21s. Into root 3 by 4. By 4 can be taken with this 21. So 21 by 4 into 22 minus 21 root 3. Or you can stop here, no problem. So this is the final answer. Okay. So this, or you can stop here. This will be the area of the segment. Okay, this problem was a little bit difficult, but in some other question, some numbers will be given that we can simply find out the answer. So here many root 3 and something came. The final answer not looking like a good simple number. Okay. Anyhow, like this, we can find out the area of a segment. Finding the area of the sector first, then the area of the triangle, then subtracting the area of the triangle from the area of the sector, you will get the area of the segment. Okay, so what we studied is, we revised the formula for arc length, that is x by 360 into 2 pi r, and the area of a sector, that is x by 360 into pi r square, and the area of a segment, that is subtracting the area of the triangle from the area of the sector. Okay,